For lesson 5.3, we're going to look at sequences. A sequence is a list of numbers in a specific order, and the term is each element in a sequence. So for this first example, we have to complete the table. So if you look at the top row for the position, we're missing a few boxes, and it looks like we're just counting by ones here to fill in the missing values. Looking at the term of the sequence, f of n, the function, the answer, we're adding 2 every time we move over. So this missing one here would be 15. Add 2, we get 17. Add 2, we would have 19. Add 2 is 21, and add 2 is 23. So you're just figuring out what's the pattern and using that pattern then to fill in the missing numbers. Here, the function of 1 is, the answer would be 9. 4, the answer would be 15. Function of 8, the answer would be 23. And then our last one, the function of what gives us 13? Well, the function of 3. Describe the domain of the function in the table. The domain is the x values, and that would always be our first thing listed in our table. So looking at those numbers, to describe those, it looks like whole numbers greater than 0, because we could continue on with this chart. Whole numbers greater than 0. The go-kart racing track records the number of gallons of gas they have at the beginning of each day. The numbers form the following sequence: 25, 21, 17, and it continues on. Predict the next term in the sequence and justify your answer. So we have to look for a pattern here. How are we getting from 25 to 21 and then from 21 to 17? 25 to 21 would be -4. And then 21 to 17 would also be -4. So our pattern is to subtract 4. So to find the next term, we would do 17 minus 4, which would be 13. So our next term would be 13 in this list. And to justify our answer, we figured out what the pattern was, which was -4. So we just continued on with that. Vocab word here is an explicit rule, and that is for a sequence that defines the nth term of a function of n. They can be used to find any specific term in the sequence without creating a large list. So this example here is going to show us how to use an explicit rule. It says find the first 4 terms of the sequence defined by the explicit rule f of n equals n squared plus 1. Assume that the domain of the function is the set of whole numbers greater than 0. So the first 4 terms, we would have to plug in 1, 2, 3, and 4 into this equation for n, because n represents the number of the term we're trying to find. So what the definition means is that we could find a specific term without creating a large list. Is if I wanted the 100th term, I could just plug in 100 for the n, and I would have the 100th term. I wouldn't have to make the list of all the 100 numbers to get there. So to find the first term, we're going to find f of 1. So we are going to put in 1 for n. So we have 1 squared plus 1. 1 squared is 1, plus 1 is 2. So the first term would be 2. And then we have to plug in 2. So 2 squared is 4, plus 1 is 5. And then we have to plug in 3. 3 squared is 9, plus 1 is 10. And for the fourth term, 4 squared is 16, plus 1 would be 17. So those are our first 4 terms. Find the 20th term of the sequence defined by the explicit rule f of n equals n squared plus 1. Assume that the domain of the function is the set of whole numbers greater than 0. So we are going to find the 20th term. We have to plug in 20 for n. So we're going to have f of 20 is going to equal 20 squared plus 1. 20 squared is 400, so 400 plus 1 would be 401 for our 20th term. The number of 121 is a term of the sequence defined by the explicit rule f of n equals 3n minus 2. Assume that the domain of the function is the set of whole numbers greater than 0. Which term in the sequence is 121? Justify your answer. So they plugged in the number of the term and they got 121 out as an answer. So we have to work our way back. The answer was 121 and they did 3n minus 2. So we have to solve for n. So we're going to add 2 to both sides. So we have 123 equals 3n. And then we'll have to divide both sides by 3. And we'll have n equals 41. So the 41st term, the answer is 121. Now we're going to take a look at the recursive rule, and that's for a sequence that defines the nth term by relating it to one or more previous terms. It can't be used to find a specific term. So the recursive rule, we would have to make out the list. We can't find the 50th term in the list quickly. We'd have to actually make out the list if we have the recursive rule. So the first thing that you always get in a recursive rule is the first term. So they tell you what f of 1 is. So that is automatically 4. They tell you that right off the bat. And then to find the next term, we're going to take the number of the term and subtract 1. So, and then add 10 to that. So the previous term plus 10. So n minus 1. So we're going to take whatever, if we want the second term, we're going to minus 1 from that. So we're going to take that first term and add 10 to that. So that's what that n minus 1 is telling us. It's telling us to take the term before, and then the rule is add 10. So to fill out the rest of this chart, we are going to have to add 10 to the 4. So that would become 14. And then the next one, we'd have to add 10 to the 14th, so we get 24. And then we have to add 10 to 24, so we would get 34. For this one, write the first 4 terms of the sequence defined by the recursive rule below. F of 1 is 3, so our first term is 3. And then this means the previous term. So we're going to take the term before and we're going to add 2 to it for each whole number n greater than 1. So as long as we are having our terms are larger than 1, so our n values are larger than 1, this rule works. So if I take the previous term, which is 3, and our rule says we have to add 2. So this is going to be 5. So if I wanted to rewrite this equation, so f of 2, as we're finding the second term, then f of 2 minus 1 plus 2. So we're going to take the function of 1, so 2 minus 1 is 1, so the function of 1 and add 2. So this would be 3 plus 2. The function of 1 is 3, and add 2. And then we're going to add 2 again. So this would be 5 plus 2, and then this one is going to be 7 plus 2, so that would be 9.